Hello everyone, engineering statistics and linear algebra. All these concepts are discussed in previous videos. Today we do solve some of the problems. A bivariate PDF for the discrete random variables x and y is 0.2 into delta of x into delta of y plus 0.3 into delta of x minus 1 into delta of y plus 0.3 into delta of x into delta of y minus 1 plus c into delta of x minus 1 into delta of y minus 1. For this, what is the value of the constant c? What are the PDFs for x and y? They are nothing but fx of x and fy of y. They are called as a single random variable probability density functions, also called as a marginal densities. What is a bivariate cumulative distribution function when x and y's are varying from 0 to 1? What are fx of x, fy of y? We know this term is nothing but a single random variable cumulative distribution function because a random variable y is having a possible event here. This term is nothing but a single random variable y because a single random variable x is having a possible event. This concept is already discussed. And are x and y independent? Let us see at the end. To calculate this problem, we should know these two formulas. Integration of delta of x, that is integration of impulse signal, is always a unit step function. Its value is always 1. The second formula, integration of a shifted impulse function, gives a shifted step function. Its value is also equals to 1. It start from the origin, it start from a value x0. These two formulas are very important as a calculation point of view here. What is the value of constant c? We know that volume in a bivariate PDF surface is 1. It is a property of a bivariate probability density functions. Substitute the value of a bivariate PDF, integrate with respect to x and y. As a result, from the first term, 0.2 is a constant, to take it outside. Integration of delta x into dx, it can be replaced by a value u of x, that is nothing but 1. Integration of delta of y into dy can be replaced by u of y, it is nothing but 1. From the first term, only 0.2 is remaining. Similarly, from the term 2, 0.3 is constant, to take it outside. Integration of delta of x minus 1 into delta of x, it is u of x minus x naught, that can be replaced by a value 1. One more term is here, integration of delta of y into dy, that can be replaced by u of y, that is nothing but 1. From the second term, 0.3 is remaining. Similarly, 0.3 from the third term, c from the fourth term, that should be equals to 1. After simplification, a value of c will be 0.2. 1 minus 0.8 gives a value of c as 0.2. Alright, what are the PDFs for x and y? They are nothing but fx of x, fy of y. A calculation of single random variable probability density function using a bivariate probability density functions. Fx of x can be calculated by integrating a bivariate PDF with respect to y. A single random variable y, its PDF can be calculated by integrating a bivariate PDF with respect to x. Substitute a bivariate PDF, integrate it with respect to y. From the first term, 0.2 and delta x will be constant to take it outside, because this term is being integrated with respect to y, so that zero point 0.2 and delta x are constant to take it outside. Remaining term is integration of delta of y into dy gives u of y that can be replaced by a value 1. Similarly, from the second term, 0.3 into delta of x minus 1 are constant, take it outside, so this can be replaced by a value 1. Similarly, from the third term, 0.3 into delta of x are constant, to take them outside. As a result, only these terms are remaining. Do the simplification. 0.2 plus 0.3, 0.5, 0.3 plus 0.2, 0.5. So fx of x is 0.5 into delta of x plus 0.5 into delta of x minus 1. Calculation of fy of y, integrating a bivariate PDF with respect to x. Substitute a value of bivariate PDF, integrate with respect to x. From the first term, 0.2 and delta y are constant because it is being integrated with respect to x. So 0.2 and delta y are constant, take them outside. Integration of delta of x into dx can be replaced by u of x, that can be replaced by a value 1. From the first term, only 0.2 and delta y are remaining. From the second term, 0.3 and delta y are remaining. From the from the third term, 0.3 and delta of y minus 1. From the last term, 0.2 into delta of y minus 1 are remaining. As a result, do the simplification. 0.5 into delta of y plus 0.5 into delta of y minus 1. Right. Next, calculate a bivariate cumulative distribution function when x and y's are varying from 0 to 1. Using inverse relation of a PDF find a CDF, a bivariate CDF can be calculated using a bivariate PDF by integrating it with respect to x and y. This is a property of a bivariate PDF that already discussed. Substitute the value of bivariate PDF, change the limits from minus infinity to plus infinity to 0 to 1, and here a shifted signals will be 0 because x and y's values are considered here from 0 to 1. A shifted delta of x minus 1, it is existed at 1 and onwards. This delta of y minus 1 is existed at 1 and onwards, but considered the value of x and y's are only from 0 to 1. As a result, delta of x minus 1 is 0. 0 is multiplied with anything will be 0. Here this term is 0 because it is a shifted signal, it is existed from 1 and onwards, but y is considered only from 0 to 1, so that this term is 0. 0 into anything, it is 0. Fourth term is also 0 here. Only first term is remaining because it is existed, it falls in these two range. X is varying from 0 to 1, y is varying from 0 to 1. It is existed in those reasons, so that all these terms will be 0 and it is not 0 here. Now 0.2 is a constant, take it outside. Integration of delta of x into dx can be replaced by u of x, that can be replaced by a value 1. Integration of delta of y into dy is uy, can be replaced by 1. As a result, only 0.2 is remaining here. So a cumulative distribution function of a two random variables x and y is 0.2. The condition is x and y's are varying from only from 0 to 1. Alright, let us calculate fx of x, fy of y. A bivariate cumulative distribution function is nothing but here fx of x, because a random variable y is providing a possible event, so that this term is nothing but fx of x here. It can be calculated by integrating PDF with respect to x. This is the formula. We have calculated fx of x, substitute here, integrate this with respect to x. Consider the first term. 0.5 is a constant, take it outside. Integration of delta x into dx can be replaced by u of x here. Integration of delta of x minus 1 into dx can be replaced as u of x minus 1. So as a result, fx of x equals to 0.5 into u of x plus 0.5 into u of x minus 1. Similarly, fy of y, this term is nothing but fy of y, that can be obtained by integrating PDF with respect to y. We have calculated fy of y, substitute here, integrate with respect to y. 0.5 is constant, take it outside. Integration of delta of y with respect to y is u of y, that is written here. 0.5 integration of delta of y minus 1 into dy can be replaced by u of y minus 1. So fy of y, fx of x, they are calculated. They are nothing but a single random variable cumulative distribution functions here. The last question is, x and y, are x and y independent? I will give you a hint here. To say that x and y's are independent in nature, this condition should be holds good. A bivariate PDF should be equals to multiplication of individual PDFs. A bivariate PDF is given. We have calculated a single random variable PDFs, fx of x and fy of y. Can you conclude by your own, are x and y independent? If LHS equals to RHS, then you can say that x and y's are independent in nature. Else they are dependent. So all these values are calculated. Conclude by yourself, and your result should be written in a comment box, whether they are dependent or independent. Check it by your own and see the result in a comment box. Alright, next we solve the next problem. A bivariate PDF for a discrete random variable x and y is a 0.3 into delta x into delta y plus 0.2 into delta of x minus 1 into delta y plus 0.3 into delta x into delta of y minus 1 plus c into delta of x minus 1 into delta of y minus 1. What is the value of the constant c? What are the PDFs for x and y? They are nothing but fx of x and fy of y. What is a bivariate CDF when x and y's are varying from 0 to 1? What are fx of x and fy of y? A single random variable cumulative distribution function of x and y. Are x and y independent? Let us see at the end. So to calculate the value of c, use a volume in a PDF surface is always 1. Using this property of a bivariate PDF, a value of c can be calculated here. A bivariate PDF is given, substitute, integrate this equation with respect to x and y. From the first term 0.3, second term 0.2, from third term 0.3, and from the fourth term c are remaining, because remaining terms will be equals to 1. As a result, value of C is 0.2, 1 minus 0.8. What are PDFs for X and Y? It is nothing but a calculation of fx of X and fy of Y. To calculate fx of X, integrate a bivariate PDF with respect to Y. A bivariate PDF is already given. Integrate with respect to Y so that from the first term, 0.3 into delta of X are constant because it is being integrated with respect to Y. So integration of delta of Y into dy that equals to u of Y that can be replaced by a value 1. From the first term, 0.3 into delta X is remaining. From the second term, X terms and 0.2 are constant. Take them outside. From third term, 0.3 and X terms, they are constant. Take them outside. As a result, we do get this equation. After simplification, fx of X will be 0.6 into delta X plus 0.4 into delta of X minus 1. Similarly, a calculation of a single random variable probability density function of Y that can be calculated by integrating bivariate PDF with respect to X. Substitute the value of bivariate PDF here, integrate with respect to X. From the first term, 0.3 and Y terms are constant because it is being integrated with respect to X. 0.3 and Y terms, 0.2 and Y terms, 0.3 and Y terms, 0.2 and Y terms should be taken outside. As a result, integration of a delta of X gives a value u of X that can be replaced by a value 1. Do the simplification here. 0.3 plus 0.2, 0.5. It is also 0.5. So fx of X and fy of Y are calculated here. Next, a calculation of a bivariate CDF when X and Y's are varying from only 0 to 1. It can be calculated using inverse relations of a CDF and PDF. Substitute the value of PDF here, and these two limits should be replaced by 0 to 1 because this is the given condition here. One more thing is here is when X and Y's are considered from 0 to 1, then shifted signals will be 0. Consider delta of X minus 1. It will be 0 if X is varying from only 0 to 1. A delta of Y minus 1 is not defined if the Y is varying from 0 to 1. So shifted signals in this range becomes 0 here. So that from the second term, because of this delta of X minus 1, complete second term will be 0. It is 0. Anything multiplied with 0 is 0 here. Third term, because of this signal, everything will be 0. And fourth term is also 0. What is remaining? The remaining term is only first term. And from the first term, 0.3 is a constant, to take it outside. Integration of delta of X, integration of delta of Y. That can be replaced by u of X and u of Y. As a result, only 0.3 is remaining. U of X and u of Y, replace them by a value 1. A cumulative distribution function equals to 3. The condition is X and Y's are varying from 0 to 1. Next calculation is calculate fx of X, fy of Y. It can be calculated using this formula. A random variable cumulative distribution function can be calculated by integrating probability density function here. Fx of X can be calculated by integrating a PDF with respect to X. Fx of X is already calculated here. Substitute the value of fx of x, integrate that with respect to x. From the first term, 0.6 is a constant, to take it outside. Integration of delta x into dx can be replaced by u of x. From the second term, 0.4 is a constant. Integration of delta of x minus 1 into dx is u of x minus 1. Similarly, calculation of fy of y. It can be done by integrating a PDF with respect to y. A single random variable PDF is already calculated. Substitute in the equation, integrate with respect to y. From the first term, 0.5 is constant. Integration of delta of y into dy is u of y. That is written here. From the second term, 0.5u is a constant, to take it outside. Integration of delta of y minus 1 into dy is u of y minus 1. So both fx of x, fy of y are calculated here using these relations. The next concept is, the last point is, are x and y independent in nature? It's this task is for you people. I will give you a hint. A bivariate PDF should be equals to a multiplication of an individual PDFs. So we have calculated a bivariate PDF is already given. We have calculated fx of x and fy of y. So multiplication of these two should be equal to a given bivariate PDF. If that is the case, the given x and y's are independent, else they are dependent. So simplify, get the result, and tell me your answer in a comment box. Next, the assignment problem. Same problem, values of constants are slightly changed here. So follow the video and try to solve this and write it in an assignment book. So if you have any doubts means, feel free to ask me, and like, share, comment on the video, and don't forget to subscribe the channel. In the next video we'll solve one more type of problem on CDF and PDF. Thank you.